Welcome back everyone. In our last video we set up variables. Today the magic happens. We're going to apply core programming logic and techniques that are used in building games to actually make our character move. We will read what keys you are pressing on the keyboard and use that input to push our player left and right. If you haven't already done so, go ahead and open up your player controller script. First we need a new box to store the player's keyboard input. Underneath our public variables, we're going to type in private float horizontal input. We use private here because we don't need to see this in the inspector. The computer will handle it behind the scenes through the code. Now jump down inside your update method. Remember, this runs every single frame. We need to constantly ask the computer, is the player pressing a key? Go ahead and type in horizontal input equals Input.GetAxisRaw horizontal. This built-in Unity command automatically checks if the A or D keys or the left and right arrow keys are pressed. It returns a -1 if we press left, and a +1 if we press right, and a 0 if we press nothing. We now know when the player wants to move, but how do we physically push the character? We have to tell our script to talk to the physics component we added in video 3. At the top, under your input variable, type private rigid body 2D and give it the name RB. RB is just a quick name that we are giving it. Next, we have to link that nickname to the actual component on our character. Inside the start method, which runs exactly once when the game boots up, type in RB equals GetComponent rigid body 2D inside of these greater than and less than symbols here, and then don't forget to add the parentheses and semicolon at the end. This line tells the script, hey, look at the object I am attached to, find the rigid body 2D and store it in the box we've named RB. Now for the movement. In our update method below our input code, type in the following line. Unlike previous versions of Unity, Unity 6 uses linear velocity instead of just velocity. So let's break down this programming logic. We're setting our linear velocity or speed of our physics body. We give it a vector 2, which simply means a speed for the x-axis and the y-axis. So a speed for left and right and a speed for up and down. For the x-axis, we multiply our keyboard input, -1 or 1, by our move speed variable. So if our speed is 5, pressing right means 1 times 5, moving right at a speed of 5. Pressing left means -1 times 5. We move left at a speed of -5. For the y-axis, we just tell it to keep doing whatever it's already doing by typing rigid or rb.linearvelocity.y. Now, save your script, let it compile, and then press the play button. I do want to point out here that our code is using the old input system package. I will make a video that shows how to utilize the new input system package, probably as a bonus to this project. So if you get a red error, then the way to fix it is you're going to go to Edit, Project Settings, make sure you're selected on the player. Under Other Settings, scroll down until you see Active Input Handling. For now, you can press both. We will do this, but with this notice here that says it's going to be deprecated. It's a legacy feature. It's not recommended for new projects. It wants us to use the new system package. So I'll probably make a follow-on video instead of a bonus video, and it'll be right after this one. Yeah, So once you select both, it's going to prompt you to restart Unity. Go ahead and restart it, and then it'll pop back up, and then you'll just have this yellow error here. So now that we have that out of the way, let's go ahead and press play and see what happens. Alright, the player's moving left and right, but he's not flipping and facing that direction. So let's go ahead and fix that. Back in our update method, we can use an if statement to check which way we're going if we type in the following lines. If horizontal input is greater than 0, then we're moving right. We set the local scale of our transform to 1, 1, 1. If it's less than 0, then we're moving left, and we set the X scale to -1, 1, 1, which flips the image horizontally. Save your code and let that compile. Let's test it out. Alright, we're moving right, and now we're moving left. Look at that, we have a character that runs across the stage and faces the correct direction. Give yourselves a round of applause. You just wrote your first functional game mechanic. In video 6, we're going to dive into jumping and gravity using math and physics to apply vertical force to our character. Keep learning, keep building. I'll see you in the next video.